All right, this is my Physics Lab 3, looking at the magnetic field influence of a bar magnet. Okay, so for the table of contents, we got the introduction, data and observations, code, discussion, and conclusion questions. So introduction, the purpose and fundamental principles of this lab. The purpose of this lab is to see the influence of magnetic field from a bar magnet and predict how this influences different observation points using the Biot-Savart law. In the preview of the results, bar magnets have magnetic dipoles, which moves objects in the direction from south to north on the parallel axis and north to south on the perpendicular axis. So the Biot-Savart law, this law acts as the relations of magnetic fields to the current of the source and seeing how charge density and distribution influences the force on the surrounding points of observation. This equation can also be altered to account for magnetic dipoles, and that is the equation on the bottom, looking at the magnetic field constant, in this case on the parallel axis, with the 2 magnetic dipole and then displacement cubed. You can get rid of the 2 in order for it to be a perpendicular and do opposite. So for the experimental model, our system was the phone with the magnometer app. The surroundings was the bar magnet, and the magnets of the Earth should also be considered in the surroundings because magnetic field does influence of the Earth does influence magnetic fields on Earth. So the sensor needs to first be zeroed on the north and south axis and then move to the east and west axis to make sure that it is properly zeroed out. For distances, there are my observed distances and also my perpendicular collections. The distances were needed in order to collect locations where the magnetic field was equal to 20, 70, 120, 170, and 220 microteslas. And these were perpendicular axis magnetic dipole equation in order to find the magnetic field influence, which is at the bottom. That was what we observed. For observations, when the magnometer is far away from the magnet, it measures a near zero magnetic field. That is true. As the magnometer moves closer, it does not. The position has no effect. It does not. And as the magnometer moves closer to the magnet, the measured component increases. Yes, it does. So moving into the code, a couple things that needed to be done. The dipole definition needed to be made. The equation needed to be set for the constant, the magnetic constant. And then values needed to be calculated based on or off axis, which would also factor into the model where the arrows would point and how that influenced the structure of the model. So looking at the model, overall magnitude was found to be 1.57 e to negative 10 teslas. The x was 8.06 negative 6, 10 to the negative 6, and the y was 2.6 times 10 to the negative 6. And this was in comparison to our observed values, which are below in that spreadsheet. And this is the model right here, which makes sense because we have the red parallel axis going from the south to the north direction because the south attracts while the north repels. So then on the perpendicular axis, which are the blue lines at the top and the bottom, you can see that it's actually going from north to south instead of south to north, because the perpendicular axis is always flipped in comparison to where it is on the parallel axis and also slightly weaker. And then you have the magenta arrow up at the top, which is looking at a random observation location, which makes sense with the typical movement of a magnetic field where it would loop around, similar to that of an electric dipole. So looking at our what ifs, the first what if was how would it change if the phone was left at an angle and Earth's magnetic field was not ruled out. The components of the magnetic field would have been measured as off by a little since Earth's magnetic field would have influenced them. And then the other one was, what would it be like if the 2 bar magnets were attached together and then influencing the phone? And the experiment would be the exact same, but the magnitude of the forces would increase by a certain magnitude, which would be a scale factor depending on how the magnet influences them. Thank you.